Morning to all of you. As you all know, this side Gaurav Srivastava sir from Engineers Institute of India with 14 plus years of teaching experience as GATE Chemical Engineering Educator, author, multiple GATE top ranks with current year AIR 43. So today we are going to discuss few important killer concepts that will definitely kill any question from this filtration topic. Okay? सर पैक्ड बेड में फ्लो रेट का डायामीटर से क्या रिलेशन है? किया दास आस्क्ड, पैक्ड बेड में फ्लो रेट का डायामीटर से क्या रिलेशन है? बेटा, whenever you are seeing the relationship of flow rate etc with diameter or pressure drop for these type of cases generally, then these things will be discussed in fluid mechanics. But here the part that you are completing, if you are asking beta flow rate, what is the meaning of flow rate? Either it can be mass flow rate or it can be volumetric flow rate. If you are talking about mass flow rate, then what is this? If you are going to multiply this area with velocity, what is this? This is volumetric flow rate. This is volumetric flow rate into density. Now what is this? This is, you can see, mass flow rate. So my dear students, clearly you can see if you are going to decrease diameter, that means area will be decreases, and then for same mass flow rate velocity will be increases. Okay, and these things in detailed manner you will see in subject fluid mechanics with the help of continuity equation, with the help of Bernoulli's equations. Okay beta, kya dash, is it crystal clear? And also if you want to write the flow rate here in case of packed bed, so here just you can write by using this formula, that is m dot is equals to a. This a for your packed bed is cross sectional area of your packed bed. This is not the surface area of a particle beta. Okay, and this is what here you have to multiply with superficial velocity into rho. This you are going to use for your packed bed or fluidized bed. Okay, this you are going to write for packed bed or fluidized bed. I hope everything is crystal clear, beta. Kya das? Shall we move forward, my dear students? Because if this is your packed bed, beta, or fluidized bed, either packed or fluidized, these are particles. These are particles. You know law of conservation of mass. Mass can neither be created nor be destroyed. Only it can transform from one form to another form. Then the mass that are going to enter from this cross section, definitely here also the mass flow rate will be same. Only the difference is there that inside will be more turbulence, because the effective area when it enters into the packing will be decreases. So here velocity will be increases. Only these thing happen after entering. But you know, if 10 kilogram enters from here, then definitely 10 kilogram will be exited from here if the process is happens at a steady state beta. Okay, so that's why here you are going to multiply ax, that is cross sectional area of the tower, multiplied with the velocity here, that is v naught bar, superficial velocity, multiplied with density of this fluid. Okay, गुड, वेरी वेरी हैप्पी गुड इवेनिंग बेटा श्यान मुखर्जी सर। कुछ क्वेश्चंस में डाउट था। क्या दस होमवर्क क्वेश्चन यू आर आस्किंग अबाउट होमवर्क क्वेश्चन बेटा श्यान मुखर्जी ने क्या दस जो होमवर्क दिया था उसके बारे में पूछ रहे हो क्या? होमवर्क क्वेश्चंस, डाउट्स इन होमवर्क क्वेश्चंस, प्लीज टेल मी एवरीवन। डाउट्स इन होमवर्क क्वेश्चन बेटा? yes sir, okay. So beta homework question I will discuss after completing this chapter filtration. Then one class will be there, doubt clearing session. In that session beta you can ask all homework questions. Okay beta, done. And also please share question number on telegram so that I can prepare slides before the start of class, so that we can save some time during class. अगर पहले से आप भेज दोगे तो हम पहले से स्लाइड बना लेंगे, तो क्लास के टाइम में उसको ऊपर से कॉपी पेस्ट करने में समय हमारा नहीं खराब होगा. तो जस्ट शेयर मी क्वेश्चन नंबर, विच क्वेश्चन नंबर, नॉट हियर, जस्ट सेंड मी ऑन टेलीग्राम सर दिस क्वेश्चन नंबर यू हैव टू डिस्कस इन योर डाउट क्लियरिंग सेशन. Okay, answer keys I will share soon beta, I will share soon, because still I'm not getting response from all of students. Lots of students still doing. So I am giving you just one more day. Okay, before doubt clearing session I will share answer keys. Okay, so can we start today's session, beta? Everyone crystal clear? This doubt is clear, beta? Just write crystal clear in comment section, beta. Asked by Kiadas. Please tell me, beta, Kiadas, is it crystal clear? Clear, sir. Okay. So now here I want to ask you one beautiful question. Can we use Argon equation in cake filtration for calculation of pressure drop? Or can we use Argon equation, or can we use Cosny-Kármán equation? Can we use Cosny-Kármán equation? Can we use Black-Plummer equation? Can we use Black-Plummer equation? Or can we use these all three for cake filtration for the pressure drop across cake? Across cake. What I am telling here, my dear students, what I am telling here, just focus here. Just focus here. Suppose this is your porous media. This is your porous media. What is this? This is your porous media. This is your porous media. Okay, fantastic, mind blowing, super. This is what? This is your porous media. What is this? This is your porous media. Porous media. Now, just what I want to ask you, I am asking that if filtrate is coming from here, and if from bottom you will get filtrate, definitely, but the solid present in your filtrate are going to accumulated on the surface of the porous media as a cake, as a cake. Okay, and now what is happening here? The slurry that you fed here, from bottom you are getting filtrate, you are getting filtrate. So what I'm asking here, my dear students, just I'm asking that for this cake, if we want to calculate how much pressure drop across this cake, I want to calculate how much pressure drop across this cake. So can we use any of these three equations here? If yes, then please write the equation name in comment section. If all equations you can use, then write all equations we can use, sir. If you can't use, you are thinking like this, then please write we can't use any equation. Everyone, beta, please tell me. And please reply in comment section little bit faster, little bit in faster way, beta. सभी लोग फटाफट बताएंगे. Everyone, please tell me. Please confirm me, everyone, beta. Can we use? If unable to give answer, then you can write R in comment section. That means sir unable to think what to do. क्या करना है? I don't know, sir. Still waiting for your comments. Everyone, please, beta. Everyone, please talk to me during class, just like offline class. Okay? जैसे offline में बच्चों से पूछते हैं and they replied immediately. So I want the same reply from your side. Please reply immediately. Don't know any medium. That means you are saying that any equation we can use. Okay. So my dear students, the right answer is you can't use Argon equation. You can't use Black-Plummer equation, but you can use Cosny-Kármán equation. Can you tell me what's the reason behind it? What's the reason behind it? Because here, with the help of lots of experiment, it had been seen that after cake, the flow rate of filtrate is in laminar manner. The flow that is happening here is in laminar manner. Laminar flow. Okay, laminar flow. That is flow through cake. Because you know, whenever you are going to use any porous media, like in Hindi you have some foam type material in your home. Just uh, take some slurry, like suppose slurry is just oil and water mixture, and put there on the surface. From bottom, is there a turbulent flow? Are you getting turbulent flow? But please tell me everyone, क्या bottom से आपको sponge through sponge, the flow that you are getting from bottom, is it turbulent or laminar? What is turbulent flow, what is laminar flow, you will see in detailed manner in the fluid mechanics. Just here you have to feel that laminar means the flow is in a very very good manner, like the layers are not going to cut each other. And turbulent, that means totally mixed type flow, lots of eddies are there. And these things you will learn in detailed manner in fluid mechanics. Everyone please tell me, beta, are you getting my words? So that's why here you can use what, only cosmic carbon equation. So the conclusion is what is conclusion here? What is our conclusion here? What is our conclusion here? We can use we can use cosmic carbon equation for the for the calculation of delta PC. What is delta PC? Now no need to write delta PC across cake, because if I'm writing delta PC, that means pressure drop across cake. Okay, everyone crystal clear, beta? Shall we move forward? Please show me your energy. Shall we move forward? No doubts at all. Okay, fantastic. So next beautiful heading, that is derivations relating cake filtration. Derivations relating cake filtration. Okay, derivations relating cake filtration. Just wait. I want to modify this diagram. Okay, now it looks better. It looks better now. Okay, so see, from this side, what is this? This is slurry. This is slurry. Okay, ये क्या है बेटा? This is slurry. Just I'm drawing the previous one diagram in vertical manner. Okay, and from this side, what you are getting? From this side, you are getting filtrate. What is this? This is filtrate. Filtrate. And this is your this is your filter media. This is your filter media. That means some porous medium. This is your filter media. And what is this? What is this? This is cake that is accumulated, solid accumulated on the surface of your filter media. Okay, बेटा बोलो, सभी को clear है? Everyone crystal clear? The same diagram. See, same diagram. Just I'm rotating like this. Okay, rotating like this. Okay, done. No doubts. Everyone crystal clear? Okay. Now, what I want to check here. एक काम करो. Here I want to write something else. Semeta. Okay. So what is this? This is your cake. This is your cake. It will be easier to feel. This is your cake, and this is your filter media. This is your filter media. Okay, done. Fantastic. Now, suppose my dear students, the pressure that is available here at this surface, at this surface. I am representing on the top is P1. Here the pressure is, suppose I'm writing like P dash. Here the pressure is P2. So first tell me P1 P2 which one is larger one, P1 or P2? इसमें से बड़ा कौन सा है बेटा? Please tell me which one having larger value. It's P1 or it's P2? It's P1 or it's P2? कौन सा बेटा है? Which one of the following? Here I am writing this as LM. Why LM, sir? It's thickness of your medium. And here L is thickness of your cake, and definitely the cake thickness is a function of time, whereas filter media thickness is not a function of time. Okay, and one more thing, here the filtrate that you are writing, my dear students, the flow is laminar. The flow is laminar. Still I'm not getting answer from your side beta. P1 P2 which one having larger value? इसमें से ज़्यादा बड़ा वैल्यू किसका है बेटा? P2 is larger one. बेटा रोशना, आप कैसे सोच रही हो? How you are telling me, Roshna, that P2 is more? The flow is starting from P1, then lots of restrictions are there. You can see cake restriction to flow, filter media restriction to flow. So losses are there na yaar beta? No, no Kiadas. Losses are there. So definitely the P1 will be larger than P2 na. Are you getting my words beta? Are you getting my words? समझ में आया कि नहीं आया? Are you getting what I want to say? P1 is more than P dash is more than P2. Okay, because restrictions are there, losses are there. Yes, Yan Mukherjee, very good beta. So P1 is more. Very good, fantastic, mind blowing, super. Okay, and here I had written LC. Let me talk something about this ELC here. What is ELC? ELC is ELC. Just write like C. So ELC is thickness of cake. Thickness of cake. LC is thickness of cake. Just tell me, if you are going to increase time, that means after some more time, if you are checking what is the value of ELC, definitely this ELC is a function of time. And if time increases, common sense, yeah, LC will also increase. More and more solid is now going to deposit it on the surface of your filter media. More and more solid is now going to become deposited on the surface of your filter media. I hope each and every student is crystal clear and no doubts at all. किसी बच्चे को कोई डाउट नहीं होना चाहिए. Okay. Now here, if I am writing pressure drop across cake, then how we can write it? If I am writing here pressure drop across cake, then how to write it beta? Pressure drop across cake. Suppose I am representing it by delta PC across cake. So what is this delta PC? It's nothing but P1 minus P dash. Very very easy to write. In similar manner, if I am writing pressure drop across media, that is filter media, if I'm writing like delta P m, so it can be written as P dash minus P2. Now please tell me, my dear students, if here I want to write overall value of pressure drop, then how to write it? Overall pressure drop, overall pressure drop, if I'm representing by just delta P. So it's very very easy. What is delta P? Just you have to add these two values. Like suppose here the pressure was 180 kilopascal Okay, here after drop it is just 100, here after drop it is just 70. So overall drop is 110. So here drop is 80 from this one, and here drop is how much? 30. So total drop is 80 plus 30 will be 110. That means I can add these two now, delta PC plus delta PM. It's very easy. It's very easy. Further, if you want to solve it, अगर आप further इसे solve करोगे, wait, if you are further solving this beta, then after solving what will get? You will get P1 minus P dash plus P dash minus P2. Now here you can see P dash cancelled, P dash P dash cancelled. So finally what you are getting? Finally you will get just P1 minus P2. So this is overall pressure drop. So now in our journey we are going to calculate this one followed by this one, and if you are getting these two, then at last just you are going to add these two pressure drops in order to get total value of pressure drop. Okay, so just write crystal clear in comment section so that we can move forward towards next slide. बोलो बेटा, सभी को क्लियर है? आगे बढ़ सकते हैं? Can we move forward बेटा? Crystal clear sir. Okay, so next heading is first we are going to calculate pressure drop across cake followed by pressure drop across media, filter media. So please write first you heading, my dear students, and beta please, if during our journey you feel a single percent of darkness in any topic, immediately beta ask me, don't allow me to move on. Okay, so only write crystal clear in comment section if in reality the topic is crystal clear to you. Okay, so the first one is pressure drop across cake, through the cake. So I'm representing by delta PC. So as you know, the flow of filtrate is the flow of filtrate filtrate is laminar. So we can apply Cosmic carbon equation here. Cosmic carbon equation here to get the expression for delta Pc. So what was cosmic carbon equation? Did you remember? It was delta P by L phi S dP rho V naught bar square epsilon cube upon 1 minus epsilon equals to 150 1 minus epsilon and whole upon phi S d V naught bar rho by mu. Just first term you are going to take and just solve this beta. क्या the sir, in actual case of filtration the cake and filter media is kept horizontal or vertical? Beta mostly you are going to arrange them in this manner beta. If you are doing cake filtration, then they are arranging like this manner beta. Okay, and sometimes it is also vertical. Sometimes it is also vertical, like in your home the candle that you are using is in vertical direction and flow is like this in horizontal manner. Okay, so here if you are going to write expression for this delta PL, then it is very easy, and this time this delta P will be, if you are writing for your cake, then it is now delta, I am writing delta PC now, because this is not overall pressure drop. Okay, sir. Okay, beta. And upon what is this L? This is L total thickness? No, no. This is thickness of your cake. Thickness of your cake. And now phi s is the sphericity of the solid particles that is available in the cake. Generally, in your question, it is not given. So from your side, you can take particles are spherical in shape. Assume and write like one. First, we have to write delta P C by LC is equals to. So here 150. Something is going to cancel here. Just check it. Uh, this square will be cancelled with this. Row will be cancelled with this row. Okay. Anything else? So now what we can write here? Delta PC upon LC. LC is the thickness of your cake, and 151 minus epsilon square. 150 1 minus epsilon, and 1 minus epsilon square. This mu will be above. And now which mu? Is it the mu of your slurry? No, it is the mu of filtrate. It is the mu of your filtrate. Okay, now the next one is what left here. One more term is there. See, v. V is also there. So this is your v. And upon whole upon phi s dp, phi s dp. So you can write here phi s dp whole square. And I think only epsilon cube left. Please check this better, because whenever these type of expressions asked in examination, I derived at the same time. I'm not going to remember. Okay, I remember only the first form. आप भी किसी भी एक फॉर्म को यूज कर सकते हो, एंड द फर्स्ट वन इज द बेटर वन टू रिमेंबर. Okay, so this is your final expression that you can use for the calculation of pressure drop across cake. Now the parameters that you are seeing here, LC. What is LC? So please write everything here. LC is LC is thickness of cake. Thickness of cake. What is delta PC? Delta PC is pressure drop across cake. Okay, very good, beta. And next one is mu f. So what is mu f? Mu f is viscosity of filtrate. Viscosity of filtrate. So why filtrate? Why you are not taking it for slurry? Because the solid particles that is present here, the thing that passed from here is filtrate. यहाँ से जो pass हो रहा है बेटा, the thing that passed from here is filtrate. Like here beta, here if this is your filtrate, this is the part of your filtrate, then this is going to pass this is going to pass this. So the flow that is crossing this cake, the flow that can cross this cake, what is this? This is your just filtrate. जो पास से कर पा रहा है वो क्या है? वो आपका केवल और केवल filtrate है. That is only and only filtrate. That's why I'm writing here mu f is equal to viscosity of filtrate. Okay, I hope that everyone is crystal clear and no doubts at all. Now, what is this V? What is this V? Sir, this time you are writing just V or not writing V naught, but it is the same to same V naught bar. So this is superficial velocity. Superficial velocity of filtrate. What does it mean, sir? How can we calculate it? It's very easy. You can write this V as Q by A. V as Q by A. What is Q? What is Q? Q is volumetric flow rate of filtrate. Q is volumetric flow rate of filtrate. I hope that everyone are feeling comfortable in this topic. Okay. So here the Q is volumetric flow rate of filtrate, and what is A? A is cross sectional area of your tower. So you can also write here, this is your volumetric volumetric flow rate of filtrate, and beta this is cross sectional area of your cross sectional area of your equipment. This is of equipment, this is not of particles that you are using there, or particles of cake. Okay. And now next one is this phi s. So phi s is what? Sparsity, disparity of solid that is available in cake. Now what is dp here? Beta dp kya hai if you want to write? So dp is particle dia. Who particle dia re bhai? Particle dia, solid in cake, one solid dia in cake, and we are assuming all particles having same dia. If it is not same, then you can take their mean. Okay, but here we are assuming that all particles are of same to same dia. Now only one thing is left, that is 1 minus epsilon or epsilon. So what is epsilon here? What is epsilon here? Epsilon kya hai yahan? It is most important part here. What is epsilon? So beta epsilon is porosity of cake. Porosity of cake. What does it mean? Porosity means what? That means how much void volume is there. How much void volume, or you can say its solution fraction. You can write it as solution fraction. What is this? This is your solution fraction. This is not the amount of solid in your cake. This is the solution that is trapped inside, that is passing, and that is available at that time inside your cake. So you can say na, it's solution fraction. Like see, these are solutions here, these are solutions here, these are solutions that passing from this one. Okay, these are solutions that passing from this cake. So the solution that is available here inside this cake, lots of solution is also there now. Yeah. Lots of filtrate is also trapped there, that I'm telling you the solution. If this is your solution and these are your solid particles, then just you have to check how much amount is white. Okay, how much amount is white. Or you, in place of solution, it is better to say that you can say it filtrate. In place of solution, you can also use it just like filtrate. That means filtrate fraction in cake. Filtrate fraction in cake. Because you are writing solution, that means solid is also there. So inside cake, how much, suppose water and some solid is there. So I am asking how much percentage of water in terms of fraction, not percentage, how much fraction of water there in that cake. That is your epsilon. That is porosity of cake. If I'm writing suppose here 1 minus epsilon, then 1 minus epsilon represents what? 1 minus epsilon represents what? Like epsilon is porosity of filter cake. So 1 epsilon is fraction of solid particles in the cake. This is what? This is fraction of solid particles. Solid particles in the cake. In the cake. Okay. So what is epsilon? Epsilon is filtrate fraction inside the cake. And 1 was epsilon, definitely that will be fraction of solid particles in the cake. Now, please tell me everyone, this slide is crystal clear. Shall we move forward towards next slide, beta? Can we proceed? Everyone, please tell me, beta. Everyone, please tell me. And here assume this as your beautiful equation number 1. We will use it later when required. Okay, आगे बढ़ा जाए बेटा. No doubts. Now what is our next work? Just we know this beautiful equation, so we are going to rearrange it, because here our main mission is to calculate what is the volumetric flow rate of your filtrate. So just I'm writing this V, the equation for V. I am rearranging this equation and writing for this V. So by equation 1, by equation 1. We are writing that equation for v. So what should be the expression for v? Please everyone write it. सभी लोग लिखेंगे इसे फटाफट यहाँ से देखकर. So v will be equals to delta p c by LC and psi is TP square epsilon cube in numerator. Okay. So delta PC by LC, then phi is dP square here and epsilon cube is also here. Okay. Let me check. This. Okay. Done. And in denominator 150, 1 minus epsilon square 150 1 minus epsilon square anything remained, yeah, mu f. And please check this beta, as again I am telling you these things, no need to remember. Whenever required, you have to solve these equations in order to get your final expression. Okay, so please mention it your as your equation number 2. This is your beautiful equation number 2. This is your equation number 2. Okay. Oh, not 1, it's 2. Done. Okay, beta. Fantastic, mind-blowing, super. Now, one more parameter I am going to define here, that is concentration of slurry. That means how much solid is available there per unit volume. That is concentration of your slurry. And how much volume what? I am writing concentration in which manner? See, how much solid is available with every 1 meter cube of filtrate. That is kilogram per meter cube. Solid present in filtrate. Weight. So I am writing here C. This is a small c, and this small c is what? This is concentration of slurry. Concentration of your slurry, and the unit is kilogram per meter cube of filtrate. Now, if here I want to check how much mass, total mass deposited on your filter media, and how much solid is present in that mass. That means, in other words, you can say how much solid is present in that cake. Are you getting my words, beta? Are you getting my words? That is mass of solid deposited in cake. Then you can write it like na, m is equal to c v. What is this, sir? ये क्या किया sir आपने? What are you doing, sir? Don't worry. Don't worry. Just focus here. This is your equation number 3, and now I am going to further explaining this beautiful equation. What is this? What is this? This is mass of solid deposited in the cake. Mass of solid deposited or available in cake. Deposited in cake. And what is this V, beta? This V is volume of filtrate that you are getting, when that amount of solid is going to deposited there. So what is C? Just I told you concentration of solid in terms of kilogram per meter cube of filtrate. So if 1 meter cube filtrate passed, then C amount is going to accumulated there. Solid, C amount of solid is going to accumulated there. So if we pass, total solid accumulated CV. Please one more time write crystal clear in comment section, beta. Everyone please write it. One more time please everyone write crystal clear. No doubts at all, beta. No doubts at all. सभी को क्लियर है? Is it crystal clear to all of you? Very good, fantastic, mind blowing, super. Everyone feeling comfortable, everyone feeling comfortable. Okay, so this equation is important. Okay, now further few more things I want to do here. So by equation 3, by equation 3, further I am moving, further I am moving forward. So that equation was, again I am writing here, so yum, and it will be more better if you want to write like yum c. Okay, or just yum random, no need to worry, because only one yum that you are going to use here, this one. What is this yum? This is mass of solid that is present in cake. See, this is your filter media, okay, and this is your cake above this filter media. We are focusing on this LC only here. And if the cross section area is AX, this is area, this is not length. This is cross section area is AX. And if we are going to multiply this AX with this LC, it will be total volume of cake na beta. Just tell me yes or no. Hmm? Are you getting my words beta? Are you getting cross sectional area into that length? Just cylinder volume yaar, pi r square h, ah. Here I'm writing a into h. Are you getting my words beta? Everyone feeling comfortable and crystal clear? No doubts at all. And because only one area here we are using, so I'm not going to write ax. Okay, just I'm writing a. So how to write this yum yaar? How to write this yum? We know the volume of cake, and just you had seen 1 minus epsilon is the fraction of solid particles in the cake. So if we are going to multiply this, then definitely we can write now a x l c into 1 minus epsilon is equal to cv. So here beta one thing is wrong, and now you have to tell what's wrong in this equation. If nothing wrong, then you can write correct, Hassan, correct. But I'm telling maybe something is wrong in this equation that I had written uh, here, and I'm not writing this as ax because only one a we are using here, that is cross sectional area. Okay, now please tell me everyone beta, please tell me everyone, please tell me everyone, this equation is correct or wrong. बेटा थोड़ा जल्दी रिप्लाई दिया करो, प्लीज रिप्लाई इमीडिएटली एवरीवन बेटा, आई वांट कमेंट फ्रॉम ईच एंड एवरी स्टूडेंट बेटा. ओके, no need to write crystal clear. You have to write equation is correct or not correct. You have to write ALC 1 minus epsilon is equal to CV. Can we write in place of EM is equal to CV? This equation is correct or not correct? Please everyone tell me. थोड़ा जल्दी रिप्लाई दिया करो, प्लीज रिप्लाई immediately everyone. If unable to understand that correct or not correct, then write R in comment section. If you're feeling correct, then write correct. Otherwise, please write wrong. Everyone, please. Correct. क्या बात है. Shan Mukherjee Kyadas, everyone is telling correct. Beta, how it is correct? This is volume, and you are writing in place of mass. One more term required here na beta, density. Density नहीं लिखोगे क्या वहाँ? Please tell me everyone. Are you getting my words? Are you getting my words beta? Density will also be there ना. Density भी तो वहाँ रहेगी ना जी. Now the question is whose density? Density किसकी रहेगी? Whose density? Density of filtrate, density of filtrate plus solid, or density of solid? Whose density you are going to write here? Tell me everyone. Very good beta Roshna. Tell me everyone. Whose density you are going to write here It should be rho f, it should be rho p, or it should be rho medium. Density of filtrate Shan Mukherjee. Everyone please tell me beta. Everyone please tell me. I want comment from every student. Show me your energy. Everyone beta. Yeah, Roshna is correct. Shan Mukherjee, you are not correct beta. Beta, you are writing volume of cake. And this is volume of solid. So you want mass of solid here. So mass of solid, so you are going to use the solid density na yaar. Are you getting my words beta? Are you getting my words? What is rho p? Rho p is solid density. Only solid that is present there in the cake. Okay, that is not cake density. आई होप ईच एंड एवरी स्टूडेंट इज क्रिस्टल क्लियर. किसी को भी किसी तरह का कोई डाउट नहीं होना चाहिए. सो जस्ट सॉल्व दिस and write what is the expression for LC. And every time I don't want to write LC here. So please write just like L. Why only L, sir? Why you are not writing as LC, sir? Because C is for cake concentration. So maybe if you're writing L and if you're writing in front of C, then while revising your notes, maybe you are writing length into concentration. So that's why is dar say I'm not writing C here. Okay, so just I'm representing the cake thickness as L. I hope each and every student is crystal clear. Okay, अगर आपने अच्छे से लिखा है then still you can leave it like LC. आप LC जैसे छोड़ सकते हो, ऐसी कोई बात नहीं है. Okay, so what should be expression for L? It is C V upon rho P A 1 minus epsilon. Okay, so what is this? This is the cake thickness, and clearly you can see beta. The volume that is going to collected is a function of time. How much volume collected? So here clearly you can see L is also a function of time. Rho P is constant, A is constant, 1 minus epsilon is constant, C is also constant because that is the concentration. That means how much solid is present with every 1 meter cube or every meter cube of your filtrate or liquid. So only the variable term here is V. That is how much volume of filtrate collected at the bottom. How much filtrate collected at the bottom. So that is the value V having the function of time. More time, more volume is collected. Less time, less volume is collected. So here you can see L is proportional to V with the help of this equation 2. इस equation की मदद से भी आप ये देख सकते हो. How much equations we got? 1, 2, 3. This should be equation number 4. Okay. सभी को clear? Everyone feeling comfortable? Crystal clear? Now what I want to do, I want to write this L in this expression here in equation number 2. So now equation number 2 becomes by equation 4, equation 2 becomes equation 2 becomes. अब equation 2 क्या हो जाएगा रे भैया? What will happen with equation number 2? Now let me check. See, this is your equation number 2. So V is equals to delta PC. Here you have to write PC because PC is a different one than delta P. And upon L, in place of L, I can write small c, capital V, and upon rho P A 1 minus epsilon. Okay, this is only delta P by L. Now phi s dP square epsilon cube and whole upon 150 1 minus epsilon square 150 1 minus epsilon square into mu f. into mu f. Okay, something is going to cancel here beta. क्या cancel हो रहा है? 1 minus epsilon cancelled with this square. Anything else you can check? 150 no, mu no, cv no. So finally you can write it as v is equals to delta pc rho p a phi s dp square epsilon cube and whole upon cv 151 minus epsilon into mu f. Okay, you can write like 150 cv 1 minus epsilon mu f. Okay, so this is your expression for v. Now this is equation number 5. Further we can rearrange this equation in some standard form, like only delta pc we need in numerator, all other terms in denominator. So see what will happen with this equation in that case. So don't write it as equation because इसे याद करने का नहीं है, so don't give it a name. Further rearrange this. V is equals to, in numerator only write delta pc, and now all other terms you have to write in denominator. Okay, so 151 minus epsilon, 151 minus epsilon, rho p phi s dp square, rho p phi s dp square, and I hope epsilon cube was also there. 151 epsilon rho p is phi. Okay, and the remaining term is mu cv upon a. It should be mu cv upon a. Let me check. Mu cv upon a. Mu cv upon a. Yeah, correct. Mu cv, because I remembered that final equation. That's just I'm cross checking. So mu cv upon a, 151 minus epsilon. Remaining is rho p phi is dp square epsilon. You're absolutely correct. Now the beautiful thing here you are going to develop, derived. You derived already. See this term beta. For cake filtration, this term is represented just alpha, and this alpha is known as a specific cake resistance. This alpha is known as a specific cake resistance. Important one, already asked in your examination, and you can find this word in lots of numericals, that is specific cake resistance. In most of the cases the value directly given there. Okay, if someone asks you what should be expression, so expression is very easy. It's 150 1 minus epsilon whole upon rho p phi s dp square epsilon cube. Okay, बोलो बेटा सभी को क्लियर? Everyone crystal clear? Can you tell me what is the unit here beta? What should be unit of this specific cake resistance beta? Unit निकाल सकते हो क्या? Can you solve this and tell me what should be unit here? Unit is very easy here. See, 150 dimensionless, 1 minus epsilon dimensionless. Rho p, yeah, having dimension, that is kilogram per meter cube. So kilogram per meter cube. Phi s sparsity dimensionless, dp square, so meter square. You have to write here. Oh my god, it's a meter per kg. So this one can also be asked in your gate examination, that what should be unit of a specific resistance. Four options will be there. Gate PSU both can ask. So it's meter per kg. Okay, very good beta. Very good. Absolutely correct beta. It's meter per kg. So finally the above equation again, if you want to write, then see this equation can be written as just delta Pc and whole upon alpha mu c v upon a. In this manner, I remembered alpha mu CV upon A. Alpha mu CV upon A. You have also, you need to remember this. Okay, because in your examination you can't derive completely. So dealing, you must know what is the dealing, and this one equation you need to remember here. Okay, this equation you need to remember here. And with the help of this equation, one more beautiful equation will come. How much equations? 1 2 3 4. Mention it as 5. Mention it as 5. Okay, and this is not the volume of filtrate water. This is V. This is velocity. This is velocity. Okay, further deriving, you can write the equation for delta PC only. So what is delta PC? What is delta PC here? You can see, you can cross multiply and you will get one more beautiful equation. So alpha mu V CVB, alpha mu V into CV. Okay. Upon A will also be there. Yeah, A is also there. See one more equation here. So derivation is important because maybe they can give you any of intermediate step there, and you need to solve that equation in your examination. So this one is one more beautiful expression. Soon you will also see application of these equations with the help of lots of numericals here, because most important topic, filtration fluoridation, for 2 mark question in your gate examination. Okay, बोल रहा सभी को क्लियर है? Everyone feeling comfortable, crystal clear? hmm? In your examination they can also ask you the equation for alpha, and now the equation that I am going to write is the most important. If you're going to compare with this equation, then one more equation you can write for this alpha. Which equations? See, this alpha can also be written as by using this equation here. So what is alpha? What is alpha? See this equation. With the help of this equation you can also write na yaar alpha. आप इस इक्वेशन की मदद से भी तो यार अल्फा लिख सकते हो. So it is delta PC, alpha is equals to delta PC upon mu V. See, delta PC upon mu V. Delta PC, okay, correct. Then A by CV. A by CV. A by CV. Further in short form, if you want to write, you can write like delta PC upon mu F V. Sir, this equation is looking little bit complex. Can we need to remember? Yes, my dear student, lots of numericals you can find in your gate PYQs here from this alpha. They can also give all parameter values, and they can ask you what is the value of specific cake resistance here in meter per kg. And just you have to put delta PC, A, CV, mu and V values there, you will get your answer. Okay, are you getting my words? Everyone feeling comfortable, crystal clear? So this is beautiful equation you are getting with the help of this equation number 6, and please mention it as your equation number 7. You need to remember it. आपको इसे भी याद करना पड़ेगा. Okay. I am mentioning this equation and the bottom equation both as equation number 7. These both equations are equation number 7. Okay, so you have two expressions for alpha. एक काम करो, यहाँ मत लिखो, अगले पेज पे फिर से देख लो. So alpha, either you can calculate like simply delta PC by mu u A by CV, delta PC by mu V A by CV, or delta PC by mu v a by m, or 150 1 minus epsilon upon rho p phi s dp square epsilon क्यू. You need to remember this complete equation बेटा. आपको ये पूरा का पूरा equation, both equations you need to remember for alpha. Both are important. Any one can be asked in your examination. The first one is more important. That's why first I'm writing this, then this one. So this is your equation number 7. Please remember this. I'm also mentioning here remember. Important. Remember it. In your examination, you can't derive it. If they are writing some intermediate equation, then you can derive there. And you can find in lots of PYQs questions some intermediate equation also available for solving filtration questions. Okay. Okay beta, so please everyone one more time tell me, shall we move forward? No doubts at all? किसी को कोई डाउट नहीं है? So here one beautiful thing is coming, that is empirical. Empirical equation for alpha. Oh my god, ये क्या है sir? What is this? Empirical means there is no derivation behind it, experimental equation. So one more equation you have for this alpha, and again you need to remember it. Sir is asked in your our question paper in PYQs. Yes, questions also asked from this empirical relation, that is very easy. Alpha is equal to alpha naught delta p to the power. Yes, alpha is equal to alpha naught into delta p raised to power smallest. Oh sure, what is this? What is this? So I'm representing this as my equation number 8. Again you need to remember it. You need to remember it. Remember it. Okay, the parameters. What is alpha? What is alpha naught? Please mention here. So alpha is simply your specific cake resistance. Nothing special. Specific cake resistance. Now, what is alpha naught here? What is alpha naught here? So, beta, this alpha naught is a constant. Alpha naught is a constant. What is this delta P? Is it total pressure drop or just pressure drop across cake? So definitely we are dealing for cake only. We are dealing for cake only. So definitely the pressure drop here that you are writing is across the cake. So you can also write this as delta PC. Now what is yes? Yes is a constant. This is also a constant. It can be determined experimentally. There is no expression for this, so determined experimentally. You need experiment. Now, few more things about this yes you need to write here. Different values we have, different values for yes, and this yes is also known as sometimes of compressibility constant here. Its values, three possible values, either it can be 0, it can be 1, or it can be between 0 and 1. It can be 0, it can be 1, it can be 0, between 0 and 1. And if someone asks you what is alpha naught, sir, you are telling it is a constant. Why I'm telling it a constant? Because when pressure value is unity, then alpha becomes equal to alpha naught. So this is the value of a specific cake resistance when pressure drop is unity. Then alpha is equal to alpha naught. And what is yes? Yes can be 0. Yes can be 0. Yes can be 1. Or yes can be between 0 and 1. So these three cases are possible for this yes. If yes is 0, just see here. S is 0. Oh my god. Delta PC to the power 0. That means 1. That means see alpha is independent. Alpha is independent upon delta P now. अभी अल्फा डिपेंडेंट ही नहीं है. With respect to time, cake thickness increases, delta pc increases. Delta pc increases, alpha also increases. That is specific cake resistance. So the specific cake resistance is not a constant value. It will depend upon delta pc. You can see with the help of this beautiful equation, and also you can see with the help of this equation, alpha is proportional to this delta pc. Now if yes is equals to 0, no need to worry here. It's alpha is not a function of delta p here. And in this case beta, your cake is known as incompressible cake. Incompressible cake. Now if the value of yes is 1, now see alpha is a function of delta p and directly proportional. Alpha is now written as alpha naught delta pc, and this time beta it is known as fully compressible cake. Fully compressible cake. And if the value is present between this, then again it is a function of delta pc. But when 1 it is termed as fully compressible, but when between 0 to 1 it is termed as compressible cake, but not completely compressible cake, but not completely, not completely. And these are empirical equations, that means no derivation behind it. So only we have results that what should the value of yes, and in that case how we can define our cake. How we can define our cake. Generally for this the value of yes lies in the range of 0.1 to 0.8. 0.1 to 0.8 generally. Most of the cases you will find the real value of yes, if the cake is compressible in nature, it's zero point 0.1 to zero point 0.8. Okay. What is the meaning of compressible in nature? Compressible in nature means what? That means if more solid is now going to deposit it, the cake thickness increases with respect to time, then the bottom solid is now going to compress there by above weight, way above that solid particle. That is the compressible cake here. Okay. So everyone crystal clear in this topic better till now? No doubts at all? So this is all about your first part, that was delta PC, pressure drop across cake. And the equation you got that you need to remember was most important for next derivation is this equation number 6. When I will write delta PC plus delta PM is equal to delta P, we need to calculate overall pressure drop here. So first part is completed. Now I'm going to start second part, that is filter media pressure drop through filter media. और empirical equation तो यही कर दिया. रुक जाओ, इस स्लाइड को हटा देते हैं. Just wait my dear students, few more seconds, slides are saving. Okay. अरे हाँ, done. So next one my dear students, filter media resistance. Filter media resistance, it is represented by Rm. Most beautiful thing in many PYQs you can find, not in all PYQs, only in many. I told you many. This RM values they are writing neglect filter media resistance, because when you are comparing the filter media resistance and cake resistance, then the value of RM is much less than in comparison to resistance that is available inside your filter cake. So if they are telling neglect it, then you can take Rm is equals to 0. No need to worry. No need to worry there. But if it is available there, then you need to calculate it. So what is filter? Media resistance. The equation for this one is also same to same, similar. And if you want to write delta Pm here, in previous case it was delta Pc upon mu u and then by A by Cv. But here the equation is similar, delta Pm by mu V, that's it. Delta Pm by mu into V. I can derive it, but no need to derive it. No any important intermediate terms are there. So in similar manner you can write for delta Pm. So delta Pm is delta sorry, yeah, this is Rm. This is Rm, not delta Pm is equal to Pm. Okay. So this is what? This is your Rm. That is filter media resistance. And again, my dear students, you need to remember this equation for Rm. Okay. So please remember it. इससे भी याद करेंगे. Remember it. Important one. Equation is important one. And please do one work for me, beta. Please tell me unit here. Everyone, please solve it and tell me unit. I'm waiting for your comments. Everyone, please tell me beta unit. Solve this and tell me answer. Tell me beta. Still waiting for your comments. Devarsh Agnihotri Roshna. Everyone getting meter inverse. Very good beta. What is this? This is Pascal. And what is the unit of viscosity? That is Pascal second, and this is meter per second. Pascal cancelled, second cancelled. Absolutely correct. 1 by meter. That is meter inverse. The right unit is meter inverse. सभी को clear? Now, if someone asks you, someone want to ask about this derivation, then the derivation from where you are getting this Rm value is with the help of Darcy's law. Darcy's law, and that Darcy's law you will see in fluid mechanics. That's why I'm not going to deal that equation here. Q is equal to delta PMA upon mu F into Rm. With the help of that equation, from that equation you are getting this one. Okay, everyone crystal clear? Shall we move forward बेटा? सभी को क्लियर है? Just write crystal clear in comment section बेटा. Waiting for your comments. Wait, in my book it is available. I'm showing its derivation. One more slide added. रुको आपको दिखाते हैं. एक स्लाइड ऐड किया हुआ है हमारे पास, but don't want to invest time there, that's why make a slide for that one. See beta, this one, these 5 steps you need here. So del C's law for flow through porous media is known as Q is equal to delta Pm A upon mu of Rn, and Q is volumetric flow rate. Now superficial velocity is Q by A, just I told you, see here. And now just you are going to write this here, so it will be Va is equals to this. Now A cancelled both side, and now you will get this one. Okay, no need to write, इसे लिखने की रिक्वायरमेंट नहीं है. ओके, सो शैल वी मूव फॉरवर्ड बेटा. किसी को कोई डाउट नहीं है अभी तक? नो डाउट्स एट ऑल. Now if we want the value of delta Pm from above equation, then it can be written as simply mu f v into Rem. I hope every student is crystal clear. Okay, equation number 8, write it as equation number 9. Okay, equation number 9 done. You need to remember this one also. Now we have equations for delta Pc, we have equations for delta Pm. That means now we are able to calculate the overall pressure drop across our filter media and plus cake. So now our next heading is what? Overall pressure drop. So overall pressure drop, or you can say total pressure drop, and that was delta P. And just you had seen delta P is nothing but delta PC plus delta Pm. Just put values here. So delta P is equals to, what was delta PC? Alpha mu CV, alpha mu CV upon A into V. So alpha mu V CV upon A. Alpha mu V, alpha mu V CV upon A, plus what is delta PM? It's mu F V R M. Mu F V R M. Now the good thing is here that in both equations you can find V is available. So just I am going to write the expression for V here. So how I can write it? I can take common V here. So V common, then what left here? Alpha mu F C capital V upon A, and plus mu F Rm. Its delta P is equals to. So if you want to write just for V, then it can be written as V is equals to delta P upon alpha mu CV upon A plus mu F R E M. You can also take mu F common, but I'm not interested to take it common because I want to rearrange it in some standard manner, like y is equal to mx plus c. Okay, so this is just rearranging. You rearranged it, and please mention it as some equation. Equation number 9. So just start equation number 10. Sir, we need to remember. No, 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 no. Now we know. Oh, wait. deciding is here. Okay, so now that we can also be written as velocity. It's a linear velocity. So can we write it like volumetric flow rate upon area? Just tell me everyone. It was just Q by A, na? You remembered? And this Q is volumetric flow rate of filtrate. That means volume collected, suppose in dt time is dv, then can we write in place of Q dv by dt? If any doubt, beta, please feel free to ask me. So if Q I am writing like dv by dt, Q I am writing like dv by dt. So now I can replace this v by dv by dt upon A. I hope each and every student is crystal clear. Okay. Now just you are going to put this value in equation number 10. So I'm writing here, now equation 10 becomes, now equation 10 becomes, now what will happen with that equation number 10? Let me check. So it's 1 by A into dv by dt. How Q is equals to dv by dt? Beta, this is your filter media. From here you are getting dv filtrate in some differential time dt. So this meter cube you are getting in this second. So this is now volumetric flow rate, meter cube per second. Is it clear, beta? Kya dash? That is volumetric flow rate of filtrate, beta. How much volume? That V is capital V. This is small v. This is velocity. This is volume. Okay, sir. Fantastic. Mind blowing. Super. Whenever you feel any doubt, beta, feel free to ask me. चलो बहुत अच्छी बात है. So now just I am rearranging it, and now I can write it like delta p and whole upon alpha mu cv, alpha mu cv upon a plus mu rm. Just check it. Yeah, we are correct. Now just you have to solve this differential equation here. Okay, so 1 by a is here. If I'm writing on that right hand side, then we can get the expression for just dv by dt. That will be dv by dt is equals to delta p and whole upon alpha mu cv upon 1 by a, it should be now a square, plus mu f rm upon a. I hope everyone feeling comfortable and no doubts till now. Okay, now suppose I am reciprocating this equation. So I am writing for dt by dv equation in terms of dt by, just reciprocating both sides. So it will be now delta p, you can write here. So a square delta p, a delta p here. So now this is a standard form that you got, alpha mu cv and whole upon a square delta p and plus mu f rm by a delta p, mu f rm by a delta p. This equation is also very very important, beta. So we need to remember all terms. Yes, yaar, you need to remember complete equation. Yaad karna, yaar. You need to remember complete equation. Even you can't forget what is alpha mu cv. It is there. No, no. Everything you need to remember, yaar. सब कुछ याद करना है. Now, when they are asking any question in an examination, then suppose they are asking, they are telling like by way we are constant that delta p we are feeling that it is constant, that is pressure drop, you are not going to allow to vary. Okay, that means even if the cake thickness is increases, the pressure drop is managed somehow as constant value. Pressure drop constant pressure filtration. So The second thing is there, that means you are not going to make it constant. Then other thing you are going to make constant, like constant rate filtration. So few more analysis we are going to do with this equation. Okay, and this is basic filtration equation, you need to remember it. So please write here in front of this equation, this is basic filtration equation, mother equation, you can say basic filtration equation. Directly from this equation many questions asked, and in a few numericals you can also see this equation is given along with your numerical. So this is basic filtration equation, please remember it beta, please remember it. I will show you lots of PYQs soon. In next lecture we will finish this filtration. Okay, अगले लेक्चर में खत्म हो जाएगा with lots of PYQs, lots of numericals. Now, as I told you, the topic was principle of cake filtration. Principle of cake filtration. And now again I am classifying this as constant pressure filtration. The first one is constant pressure filtration and the second one is constant rate filtration. So please write constant pressure filtration, constant pressure filtration, and second one is constant rate filtration. In concise form, I already explained what is constant pressure and what is constant rate. Now I am going to explain in a little bit more clear words. Constant pressure filtration, that means on both sides the pressure that is present is constant. Pressure, you are not going to change pressure, pressure is constant. Definitely if you are going to increase pressure on upstream side, then it will increase the rate of filtrate. So what I want to show here, just tell me one thing, with respect to time, with respect to time, what will happen with cake thickness? Definitely increases. And if with respect to time cake thickness increases and delta p that is available there, you are not going to change it, driving force still remain constant. What will happen with rate of filtration there? Can you tell me in comment section beta? What will happen with rate of filtration here? What will happen with rate of filtration here? Fatafat, everyone please tell me immediately. Increases or decreases? Increases or decreases? Decreases. Fantastic, mind blowing, super. Now here, for constant rate filtration, if time increases, oh my god, cake thickness also increases. Can you tell me what will happen with rate of filtration here? Rate of filtration here, increase, decrease, increase, decrease, please tell me everyone. Increase, decrease, come on, come on, come on everyone, please tell me beta. Increase or decrease? Constant. Constant. How constant? How constant? Cake thickness increases, but at the same time, in same proportion, we are going to increase inlet pressure. Now, increase inlet pressure to overcome this. To overcome this. That means delta P is now no more constant here in case of constant rate filtration. So, sir, This slide is important. Already 1 mark question asked from this slide. In that slide, just they asked in constant rate or constant pressure, one of these two asked. And suppose I'm writing for constant rate, so just they ask in or constant pressure. Constant pressure filtration, the rate of filtration decreases with time, rate of filtration increases with time, rate of filtration is constant, we can't say. So what right option is rate of filtration decreases in constant rate filtration. So definitely constant rate of filtration is constant. I think first one asked constant pressure filtration. Okay बेटा बोलो सभी को clear? Shall we move forward beta? Shall we move forward? No doubts at all. Okay, so now one by one we are going to study these two. So please write down first heading, that is constant pressure filtration. That means overall delta P we are assuming is not going to change along with time. समय के साथ ये बदल नहीं रहा है. We are assuming it is not going to change with respect to time. Constant pressure filtration. And just as I told you, you need to remember that final equation that was given as dt by dv is equals to alpha mu cv upon a square delta p plus mu f rm upon a delta p. Just tell me this one is correct or not correct. सभी लोग देख लो भाई. अल्फा म्यू सी वी अपॉन ए स्क्वायर डेल्टा पी प्लस म्यू आर एम बटा ए डेल्टा पी. 100% करेक्ट. देखा हमने लिख दिया इसे बिना देखे. You need to write like this. The beautiful thing you are going to see here, alpha is constant because delta p is constant, mu f is constant, c is constant, cross section area is constant, delta p is constant. Oh my god, these all terms behave like a constant. Mu f is constant, rm is constant. Oh my god, all terms are constant here. These both terms are constant. In this case, these both terms are constant now. Oh my god. That means we can write this equation again as dt by dv is equals to kv plus b. Sorry, you're not writing c because c already we used now. So this b is nothing, intercept here. And you know beta, very important, very important. Just in previous 5 years you can find more than one question just from this equation. So here what is k? Y is equals to mx plus c type if you are going to see it. Then dt by dv definitely represents your slope. So you need to remember this k and this b. ये बहुत इंपॉर्टेंट है, k और b को याद रखना. And in the standard form it is also written as kp, so you can write like kp. Here also you can write like kp. So what is kp here beta? Kp is alpha mu c upon a square delta p. What is b? So b here mu f rm upon a delta p. You need to remember these two values. And just this equation asked in PYQs, you can find this equation already asked in gate. Okay, like this, dv by dt is equals to 1 upon kv plus b. In this manner asked in gate, that which one of the following equation is correct about dv by dt. So just reciprocal, both sides you are going to reciprocate. Okay beta, सो ये क्वेश्चन पूछा हुआ है, ऑलरेडी आस्क्ड, this question already asked in your gate examination. Okay, so I hope every student is crystal clear. And my dear students, these two KP and B are very very important. And not writing just important, I am writing very 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 important for this chapter. So please remember it by tonight. And also just try to write after every 1 week at least one time. Any subjects you are reading, please write this equation once a week till examination, so that you are not going to forget it. Equation is very very easy to remember. Alpha mu cv upon a square delta p plus mu rm upon a delta p dt by dv is equals to. ओके, सो बोलो हो जाएगा, सभी लोग कर ले जाओगे? एवरीवन प्लीज टेल मी बेटा, कर ले जाओगे सभी लोग? ओके, so again we are going to solve this equation here. It looks like first order linear differential equation of variable separable type. So just you are going to separate variable, take limit, separate variable, limit and integrate. So dt is equals to kp, kp is constant, so kp v plus b dv limit. When time was 0, how much filtrate collected? 0. At some instant of time t, we want to check how much volume collected. So suppose I'm representing like v, so just integrate it. In left hand side you will get t, limit is 0 to t. In right hand side it is kpv square by 2, kpv square by 2. You know na what is the integration of x to the power n dx? So this is x n plus 1 by n plus 1. Same thing I had done here. So v 1 plus 1 v square upon 2, and plus here b, so it's b into just v, and here limit is 0 to v. So this can be done as t minus 0 will give you just t, and here also the lower limit will not going to exist here because it will give 0. So only the equation that you are getting kp v square by 2 plus b v. Further rearranging it in a standard form, so it can be done as t by v, and that becomes equals to k p by 2v plus b. Why I'm writing like this? Because v is a variable term and we want to draw a simple curve, simple graph in order to show it. We want to draw a simple graph in order to show it. So now you can see beta, it looks like just y is equal to mx plus c. Now it is what? It is y is equals to mx plus c. अभी ये क्या दिखाई दे रहा है? Simple, y is equals to mx plus c. So just beta you can draw one beautiful graph here. And sir, questions asked in examination, you can soon you will see. Okay, so what is this? This is y is equals to m x plus c. So here clearly you can see on y-axis we have to write t by v, and we are plotting a graph t by v versus v. Data is also in lots of numericals, can see t by v versus v data is this one. Okay, so clearly it is the graph when you are going to plot is not going from origin, it is going from here having some value of intercept. So here what is this? This is your intercept value, intercept value, and this is just b. And what was b? This was mu f rm upon a delta p. And here the slope you clearly you can see, but it's kp by 2. Many students doing mistakes in examination, that they are they are in hurry and they are writing just KP as slope. So please don't do this mistake. This is silly mistake. So please beta don't do this silly mistake in your examination. Okay, so KP by 2, and what was KP? KP was alpha mu C V upon A square delta P. So 2 is very important for you. Please don't do silly mistake. And if I am telling anything that you can do this silly mistake, then beta be careful. Okay, so be careful about this too. I'm circling it. Okay, बोल बेटा सभी को clear, everyone crystal clear. So just see here beta, you need to find the value of Kp and V, and then you have a beautiful expression for T and V. They are asking how much filtrate is going to collected in this time. Just put the value of T, you will get the value of V. Okay, so lots of numericals are there. We will solve in next lecture, and also we will see numericals since 1987 from this topic of filtration in next lecture. Okay, so shall we move forward beta? Is there any case when B is 0, that is intercept? Can it is possible that it goes from origin? क्या ऐसा possible है बेटा? आप प्रयास करेंगे, हम प्रयास करेंगे याद करने का, बट प्रयास नहीं करेंगे. बी पॉजिटिव, वी विल लर्न सर, वी कैन सर. ओके, प्रयास करेंगे ये थोड़ा सा हल्का वर्ड लग रहा है. ओके, प्रयास करो ठीक है, बट थोड़ा पॉजिटिव वे में उसी शब्द को बोलो. सर डेफिनेटली करेंगे. सर केपी में वी नहीं आएगा, एक मिनट देख लें भैया, कुछ मिस कर दिए हैं क्या? केपी में वी क्यों आएगा रे भाई? वी तो नीचे है ना. ओ माय गॉड, व्हाट यू आर सेइंग बेटा किया दास? व्हाई यू आर वॉरिंग? सी, this is your V. You are writing on X axis V. Are you getting my words beta? And this you are writing on Y axis. Is it clear? Is it clear beta क्या दास? हाँ भाई, ग्राफ में कैसे आएगा? It's T by V versus V graph. So it's slope. Oh, okay, you are telling this one. हाँ, V नहीं आएगा. Oh, I'm sorry. अल्फा म्यू सी वी वो फ्लो में याद किया है ना, तो इसलिए वी यहाँ लगा दिया. वेरी गुड. ओके, सो डन बेटा. शैल वी मूव फॉरवर्ड? Shall we move forward, my dear students? So is there any case when this B can be 0? बोलो भाई. If filter medium resistance is negligible, yes, negligible, that means Rm is 0, then what will happen with that B? That B can be written as mu f Rm upon A delta P. Actually बेटा ये पूरा याद है, आपको भी ऐसे याद करना पड़ेगा, so that you can increase your speed. So this is 0. So from here you can see, my dear student, in this manner B will also be equals to 0. Now what will happen with your previous expression yaar? If B is 0, then only this part will be left now. So let me give some name here. This new topic complete. So I'm writing this as equation number 1 again. Okay, this is equation number 2. Okay, this is my equation number 3. So right here now equation 3 becomes, now equation 3 becomes, so you can write like T by V is equals to Kp V by 2. Yeah, correct. Now in this case, if you want to draw again the previous graph, then in this case it will be more easier to draw. Just t by v versus v, and my dear student, this time it will pass from origin. Okay, pass from origin. So again the slope value is not going to change. Slope is still kp by 2. Okay, that is alpha mu c upon a square delta p 2. Okay, and few more questions they can ask from this topic, because one more beautiful problem here you can make. Clearly you can see, but in this case t is proportional to v square. So with the help of this equation, because see, kp is constant, and please beta, please be careful, you are dealing everything till now for constant pressure filtration only. Delta p is constant. If it is not constant, see the slope is also going to vary. स्लोप वेरी कर जाएगा kp c kp by 2 in slope delta p is there. And in theoretical way they can ask you, if you are going to increase delta p, what will happen with slope? Can you tell me better, what will happen with slope? Increase or decrease? Increase or decrease? What will happen with slope if we are going to increase delta p? And this delta p is overall pressure drop. What will happen with slope? What will happen with slope? Increase, decrease? Increase, decrease? Definitely it will decrease na. This is for less delta p. But whatever the delta p is there, whatever the delta p is there, हाँ लेस डेल्टा पी नीचे जाएगा? नो, ये ज़्यादा होगा, ये कम होगा ना बेटा. हाँ, स्लोप विल इट विल डिक्रीज, स्लोप विल इंक्रीज ना यार, उल्टा बोलते हो. हैं, increase slope, that means the this one is for less delta p, this is for more delta p. चलो ओके, चलो वेरी गुड देवर्ष अग्निहोत्री किया दास. Now, how they can formulate question based upon this equation? They can ask you that filter medium resistance is negligible, and they will ask if at this time the volume of filtrate collected is like V1, then they can ask you at some time T2 what should be the total volume of filtrate collected. No need to worry here, just use this proportionality value. If you are going to divide, proportionality constant will be cancelled, and because this is v square, so don't forget to write here a square. So in gate examination they can also ask questions based upon this beautiful equation. That is equation number, please mention it some equation. Which equation? It's equation number 4. It is also important. This is equation number 4. ओके बेटा बोलो, सभी को क्लियर? एवरीवन क्रिस्टल क्लियर? नो डाउट्स एट ऑल? ओके, शैल वी मूव फॉरवर्ड बेटा? शैल वी मूव फॉरवर्ड माय डियर स्टूडेंट्स? नाउ one more analysis I want to do here. Just focus again. Just you had seen that this dt by dv for this case can be written as kpv plus b. Okay, kpv plus b. Suppose I am writing this dt by dv value, dt by dv value when just time is started, when just time is started, that means our time t is equals to 0, v is equals to 0. When time is 0, v is also 0 na yaar. What will happen with this equation? It can be written as 0 plus b, that means just b na yaar. See, can we write just like b? So numerically we can feel it it is now going to give us the initial value of volumetric flow rate reciprocal. How, sir? You, sir, you are telling initial flow rate, but sir, it is v is equals to 0. It is just now going to pass. It's still not collected there, but just now going to pass from that filter media. It passed from cake and now pass just about to pass that filter media. So it is at the start of time. You can write now this as your reciprocal of initial volumetric flow rate. Are you getting my words? Why I'm writing like this? Because this having the unit of second per meter cube. It is second per meter cube. So I am reciprocating it. Reciprocal will give us flow rate. And this one is which time flow rate? When the time is 0. See here. See, feel here. Feel here. If this is your filter media, this is your cake. So what I am telling here, my dear students, I am telling that this is your filtrate and it is now just about to pass from here. So here what should be initial value of volumetric flow rate, that I am writing as our Q naught. Initial first drop that you are getting as a filtrate. So if crystal clear, then one more time beta you have to write crystal clear in comment section beta. So initial volumetric flow rate of filtrate. What is this? This is initial volumetric. Sir, can they ask question from this? Yes, beta. Initial volumetric flow rate of filtrate. Okay. I hope every student feeling comfortable. And if they are asking in your examination that please tell me the initial volumetric flow rate of filtrate, no need to worry, yaar. It is 1 by B. And you know na the value of B, just you had calculated, yaar. Eh? So that B was mu f Rm, but I delta P. Mu f Rm but A delta P. So this Q naught is nothing but can be written as A delta P upon mu f Rm. That means for constant pressure filtration, you need the value of that overall pressure drop plus cross sectional area of your filter, viscosity of filtrate and filter media resistance only. बोलो बड़ा सभी को क्लियर है? Everyone filter crystal clear? Equation number 4. Equation number 5. Sir, we need to remember? No. But they can ask, you need to derive an examination. You need to remember this form only. And this dealing only. How to deal it in examination. If they are asking, start from this equation. In order to recall what was that expression. What was that expression? You need to recall in examination. So please don't remember that Q naught is equals to A delta P upon mu of Rm. If they are asking an example, just recall it's dt by dv is equal to kv plus b. And here at the initial rate, that means v will be 0. So t by v dt by dv is equal to b. So reciprocal, it will be 1 by b. So 1 by b is Q naught. And you know what is the value of b? Because b already you remembered. Okay, is it crystal clear, beta? Shyan Mukherjee, are you getting? If any doubt, please tell me in which part you are feeling doubt, beta. इसमें कौन सा ऐसा पार्ट है इसमें फील कर रहे हो डाउट? Tell me everyone beta, please. Everyone please tell me. Q naught beta, this Q naught is initial volumetric flow rate. Initial volumetric flow rate. If t is equal to 0, how Q is not 0? Beta, when t is 0, that means you are actually, it is not, t tends to 0, just time started. In mathematical terms, we are dealing like this, we can deal like this. When t is 0, that means just when the filtration is now going to about to start, then the first drop that is going to enter from here, that should be your volume, that will be moving forward here, moving forward here, moving forward here. Now the first drop that enters from here, law of conservation of mass, the first drop that enters from here will be leaving here. The first drop that enter here will leave here. The first drop of filtrate that entered here will leave here. And why I'm telling here just B as B, because at the initial there is no cake, the thickness of this cake will be zero now. So only this filter media is present at the start. That's why here you are writing just in terms of the final expression that you are getting just in terms of filter medium resistance. So the first droplet that enters from here, that will give you no volumetric flow rate, initial volumetric. This will be move on now like this, and now pass it. So at time t is equals to 0, the droplet is here, now start filtration. So just when it will be started, this will be your value of q naught, because after when time is started, cake start forming there. And if you're not going to change delta p, the rate of filtration will decreases. So this is what, this is initial rate, this is initial rate, and definitely this will having a higher value initial, this is initial rate. Okay, with respect to time it will decrease and decrease. Is it crystal clear, beta? Roshna, Shyan Mukherjee, everyone, please tell me, beta, is it crystal clear? In Hindi, if you want explanation, बेटा जब शुरुआत होगी तो कोई केक वहां नहीं होगा, वहां पे जो पहला ड्रॉप फिल्टर मीडियम में जैसे समय स्टार्ट कर घुसने को होगा, वही वाला ड्रॉप तो उस पार जाएगा. तो जब घुसने वाला होगा उस समय आप कह सकते हो t टेंस टू 0, देन v is also tends to 0. So what should be initial volumetric flow rate? So v0 t0, so initial volumetric flow rate हमारे मैथमेटिकल एक्सप्रेशन में क्या मिला, 1 by q naught, that is q naught is 1 by b. Okay, yes sir, very good. Everyone please tell me, is it crystal clear to all of you? No doubts at all? Please everyone confirm me. If you're feeling any doubt, feel free to ask me. If you're feeling any doubt, feel free to ask me, beta. So beta, everyone crystal clear? Please write crystal clear in comment section, beta. बोलो सभी को clear है? If any doubt, beta, please ask me. If any doubt, please ask me. Devarshak knew the crystal clear. Everyone, beta, please comment everyone. सब लोग लिखेंगे, and I hope I think that's enough for today. Okay. In next lecture we will finish this filtration chapter. Same doubt, Vishnu, beta, tell me your doubt. Ask me your doubt, beta, Vishnu. You want one more time explanation? See, beta, what I am telling you, if this is your filter media, okay, this is your filter media, and you are feeding slurry, time t barabar 0, your operation not started. So now what will happen here? Actually, it is not a time t is equal, it is t tends to 0, v tends to 0. You are writing like this, so it will be negligible value. It will be negligible value. Okay, I am telling tends to 0, but writing equals to 0. That I think you are feeling in that manner a little bit uncomfortable. Don't worry. So when just time is started, at that time v is not available here, and just time is started, t tends to 0, just time is started. So the first drop out of your slurry, only the filtrate can enter here, na yaar. So the filtrate that enters here will be exited from here, and that will provide you initial drop. So this is initial flow rate, na yaar. So for this initial, if you want, in order to get in any mathematical expression, beta, you are dealing in this manner, beta. Not only in this subject, you will also find in other subjects like mass transfer rate, heat transfer rate, and many more things. Okay, so this is your initial. What is this? Is your initial volumetric flow rate. Okay beta, is it crystal clear now? Vishnu beta, please tell me, is it crystal clear now? Just write CC in comment section beta. If it is crystal clear, then write CC in crystal clear sir. Thank you sir. You are welcome beta Vishnu. चलो बड़ा, सो सभी को क्लियर है? क्रिस्टल क्लियर सर, क्या बात, फैंटास्टिक, माइंड ब्लोइंग, सुपर सुपर सुपर. सो still I'm waiting. If any doubt, then you can ask me beta, because today's lecture completed. In next lecture you will see beautiful beautiful numericals, lots of pyqs, and you will finish this chapter. Everyone crystal clear? Okay. So कहाँ गया रे भाई? Washing तो next में करेंगे. So in next lecture we will derive beautiful expression that is not available in your books, in general books. That is how you are going to deal constant rate filtration, what expressions you can use for that, how you can check that delta p value at an instant of time, and at an instant of time uh, the calculation of volumetric fluid, that is little bit easier one, because volumetric fluid is not going to vary in constant rate filtration. So these all things with lots of new numericals, with lots of pyqs, you will see in next lecture. So one more thing at last beta, if you want rank 1 to rank 100, any rank nearby these two ranks, so beta revision is the key. I must do Marzan daily, I must do Marzan daily, I must do I must do I must do Marzan daily, but in this manner definitely you will get this rank, and you will definitely join your dream job. Every time I'm repeating at the end of lecture date, so please better revise every time. Just before starting study, when you are going to start a study in any day, first see what you had completed already in previous few days, and also once in a week you have to revise complete the subject that you had completed already. A complete subject you need to revise at least once a week. All the best, take care, love you all, and very very happy good night to all of you beta. Okay, done? No doubts? Crystal clear sir. Okay beta. So now I'm going to bind this session. Take care beta, love you all. Crystal clear sir. Okay beta, fantastic. Okay beta, Rushna, Vishnu, Devarsh, and all, lots of students are not going to invest time in comments during lecture. यार सभी लोग comments कर कर पूछा करो. कुछ बच्चा ही कमेंट करता है, बाकी लोग तो बस देखते रहते हो, लिखते रहते हो. ओके, सो प्लीज एवरीवन try to connect during live class. Very happy good night beta Vishnu, good night sir, good night beta Vishnu, everyone take care beta.